So the lesson is vectors continued, yes?
Well, but how many lessons do we have vectors?
I will finalize it this week, not because this is a very important topic, so I want to spend enough time so that you don't lose it.
Could you go through the test?
If there is another test, yes.
But I mean, this one, the one we had, will you not go through the answers like you?
No, not today. Not today. Let me finish.
Okay,
Yeah.
maybe tomorrow.
Yeah, I will give you the papers back. You have the right to complain and see your papers.
Yes.
But might be we can keep it a little bit. Is Cameron absent now? Yes.
Yeah, he's like saying.
Okay, he told me. Okay, so I want to start the new lesson. So we already talked about if I have a vector and if I have a number, I already told you how to multiply a number by a vector. I just want to repeat that and try to solve a little bit more interesting problem, and that would be the lesson for today. That would be the finalized form of the geometric vector. And there is another topic, analytic vector, that vectors are not arrows anymore. They are just a pair of numbers. Working with vectors in that form is much easier than working with vectors in geometric form. But both of them are needed. This is not something that, okay, you say that I will learn the easier one and I will forget the hard one. No, both of them is actually compulsory to learn because they have different applications. Okay, so if I have a vector, so it means that I have a directed line segment. For example, this, I can call it this vector A. I have already talked about how you can construct the 2 times vector A and how you can construct 1/2 of that vector A, or how you can construct minus 2 times A. In principle, I want to talk about this topic, how you multiply a number by a vector. Yes, alpha is a number and A is a vector. So I want to talk about how we multiply a number by a vector. Okay, even though I am using the word multiply, this is different from the multiplication that you learned in primary school. Yes, in primary school you learn how to multiply 2 numbers. You haven't learned how to multiply a number by an arrow or a geometric object. This is why, even though I'm abusing the term multiplication, but this is the way it works. This operation is called scalar. If you want to distinguish it from normal multiplication, it's called scalar. A scalar means a constant number without any direction. Scalar multiplication. So today I want to talk about scalar multiplication. If someone asks you what is the scalar multiplication, you should say multiplying a number by a vector. Okay, so I want to define this for you today. So if I give you this vector, this arrow, how should I multiply 2 by that arrow? How should I multiply 1/2 by that arrow? How should I multiply minus 2 by that arrow? It's very simple. I think you remember that was the first session I was talking about vectors. The first thing that you do, if you want to construct 2A, for example, you draw a line parallel to your vector. So you just pick a point on the plane, on the whiteboard, for example, in this case, and then I draw a horizontal a line which is parallel to this one. Of course, I cannot draw it precisely correct, but you understand what I mean. In principle, you should do it precisely. So I draw this line parallel to this one. And then I multiply the length of this vector by 2. For example, concentrate here. So it means that if this is my vector, I multiply it by 2. One here, and then the other one here. Yes, so this point and that point. This point and that point. So if I ask you what is this length, you would say that this length is 2 times larger than this length. Yes? And then if the number that you are multiplying is positive, you need to keep the direction as the direction of the vector itself. If the number is negative, you need to put the arrow, the tip of the arrow, in the opposite direction. That's as simple as that. So now if I ask you what is 2A, after all these things, you would say that this vector is 2A. Is that clear? So that is the vector 2a. If I just ask you, this is simple to do, let me do it here. If I ask you what is minus 2 times a? Minus 2 times a, yes?
It's the same vector, but in the opposite direction.
Opposite direction. Actually, I don't need to do anything at all. Again, I draw a parallel line. I have already done. I find 2 times this length. I have already done. But the only thing that I need to remember, because this number is negative, by definition, I have to put the tip of the arrow on the other side, opposite to this direction. So this one, in principle, I can, let me just draw it with blue so that you can see it here. This dotted line in this direction, this one is minus 2a. Yes, it's not a very good picture, but at least you understand what I mean. Let me take that one. Okay, so there is no reason if you force yourself to draw it from here, because what was important thing about the vectors that you need to remember, there is no concept of location for vectors, yes?
Wait, so 2a is the same as a plus a?
Yes, I will come to that. But that is a very nice discovery. Even though people think that, okay, a plus a is 2a, it is trivial. It's not trivial. I want you to understand these important points. Of course, you can memorize them, and even you don't bother to say why a plus a is 2a, but this is not trivial. I just want you to feel it, okay? So we come to that at a later time. So here, 2a and minus 2a, these are the points. If you want to, you can draw minus 2a from here. It doesn't matter because you draw a line, you draw a line parallel to this one, and then you take this length here, and then you put the tip of the arrow here. This is also minus 2a, because I told you that, remember this point, there is no location associated with a vector. The things, the quantities, no, that's not a good word. The characteristics associated with a vector are threefolded, yes? One is a slope, in which slope you are drawing it, or with which slope you are drawing it. The other one is length, and the other one is direction. There is no notion of locality associated with the vector itself. Is that clear? So it doesn't matter if you draw it here or you go at home and draw it at home, but it's very hard to keep it in parallel, yes? Okay. But what about 1/2 of a? That's also clear. What should I do this time? Yes, Min?
Draw a vector with half the length of a and the same direction.
The same parallel, the same direction, but the length should be half, yes? So it means that if this is my length, let me draw it from here. Again, let me make it close so that it is easier to draw. So here I will draw this vector, this line in parallel with this one. This time I measure it with the ruler or whatever, and then I divide that length into 2, and then I separate it here. So this would be my vector. And because 1/2 is positive, I have to put the tip of the arrow in the same direction as a itself. So it becomes 1/2a. And then I can get rid of the rest. I don't need to see even the rest. Here, not here, not here. Okay? So this is the vector 1/2a. Is that clear? Okay, if I want to have negative 1/2a, then it would be the same direction, the same slope, but the opposite direction. That would be -1/2. Okay, now let me ask you, I want you to understand this. It's a little bit hard, but you haven't studied probably absolute value, but let me ask you this question. First of all, what does this mean? Okay, read this in English. Yes, Gustav?
Magnitude of a vector.
Yes, is that clear? So this means the magnitude of vector 2 times a. So how this number is related to the magnitude of the vector itself, we just learned. How this quantity and that quantity are related. Let me just tell you. If you want to show something in the picture, this means you take your ruler, you measure the size of this, you get a number. This notation represents that number. If I ask you what is this, it means that you go to your vector 2a, you take your ruler, you measure this one, and that number represents, that number is what is represented by this symbol. What is the relation between these two? No one else, Gustav?
Like 2a vector is double of a vector.
So something like this. Is that understandable for everyone?
Yeah.
So it seems that in principle you are allowed to pull these two out from this symbol. Okay, but if I have the same scenario here, and I ask you the same question, what do you put here? Yes, Rocco?
-2.
No.
So is that sensible to put -2 there? Because if you say -2, I want you to understand, this one is positive or negative? This quantity, how do you read it?
Oh.
This is the magnitude. Magnitude by definition cannot be negative, yes? I cannot say that my height is -173 centimeters. Yes, that's meaningless. It means that I'm under the ground probably. Yes, but if you can see me, it means that my height is not a negative number. Okay, but so this means that this is not possible. Yes, Abdullah? 2. Again, I have to write what? 2. Is that understandable?
Yes.
Okay. So it means that it doesn't matter what is that number, you need to put this 2. But if I write this, do you believe in that? If I want you to discover formulas, mathematics formulas. So what do you think I should put here? If I just say alpha, alpha is a real number. You remember this symbol means belongs to real number. It means that it can be positive, it can be negative. Can I write something here to make sure that this is always true? For example, can I write alpha and say that, okay, I am happy, this is always true?
Yep.
Yes or no?
Yes.
Yes or no?
Yes.
No. Yes, why not? Because you see that this is not happening here. You have 2. Yes, that I put 2 here, that was right. It was what? It was -2, but if I put -2 here, it was wrong. I have to adjust it with a negative sign and then put it out. This adjustment is called absolute value. Okay? So, if I ask you, that is unfortunate that we have the same symbol for magnitude and absolute value, because absolute value is somehow the magnitude. Yes? Because, for example, I can say that the absolute value, let me write the word, absolute value. Yes? So the absolute value of a number is the magnitude of the number regardless of its signs. Its size is important. Yes? So if I ask you what is the absolute value of 2, you would say it is 2. If I say what is the absolute of -2, what is that? How big -2 is, regardless of the number, regardless of the sign. 2 again. So this is called absolute value. So absolute value of any number, okay, is the magnitude of that number. Even though you might say, okay, I don't have magnitude for number. Yes, you can imagine, without, regardless of the number. So then the correct form is this one. So it means that if alpha is a number, is a given number, and A is a given vector, then you can write that the magnitude. This one, I read it magnitude. Magnitude of alpha A is equal to absolute value of alpha multiplied by magnitude of A. You see, I am using the same symbol, but I'm reading them differently because I know what is inside. If what is inside is a number, I don't read it magnitude. I read it absolute value. If the thing inside is a vector, I call it magnitude. So I would read it in English in this form: the magnitude of a number alpha multiplied by a vector is equal to the absolute value of the number multiplied by the magnitude of the vector. Is that understandable?
No.
No. Okay, so do you understand this?
Yeah.
That's exactly the same story.
Okay.
So the point is that if you use this symbol, if you see this symbol, what do you put in front? I'm just telling you, if you see this symbol, inside that symbol, you see a number.
Yeah.
If the number is positive, there is no difference between the number and this fancy symbol at all.
Yeah.
And if the number inside is negative, just forget about the negative sign.
Yeah.
That is the meaning. Instead of saying it in words, I am using a symbol, okay, to communicate with you.
Yeah.
When I say a square root of a square, the absolute value of a square root of 3, what is the answer?
Square root
Of 3. Because what is inside is a positive number. Who cares about this sign? It becomes this.
Okay.
And if I ask you what is absolute value of minus a square root of 2, what's the answer?
Square root
A square root of 2 again. You see, I am not asking the same question in English. I am asking it with symbols. I put the symbol and question mark there.
What is the difference then between alpha and then the magnitude of A's vector?
There is a difference, yes, you
And
see.
the
Alpha
absolute value of A.
is the one inside. The whole package inside is called alpha.
What's the difference between it being inside the package and outside the package?
So you see that there is a difference. For positive numbers, there is no difference at all.
Yeah.
So it is just a fantasy, it's a fancy way for decoration sometimes. But if there is a negative sign inside, there is a difference between this sign and this number.
Okay, so the absolute value is for the case in which alpha is a negative number.
No, and let me correct it in this way. Absolute value is for all numbers,
Yeah.
but it matters if what is inside is negative.
Okay.
In that case, you need to be careful. They are not the same thing. So what I'm trying to say is if alpha is positive, there is no difference between alpha, absolute value of alpha and alpha. They are the same. If alpha is negative, absolute value is not equal to alpha, is equal to negative of alpha. Okay, so this is the correct way. Even if alpha is 0, the absolute value of 0. What is the absolute value of 0? What's the magnitude of 0? 0 itself. So this is a little bit more advanced definition of absolute value. I don't want to spend more time on it because this one is not in your book. But I want you to understand when you write something in formulas, how you need to read the formula. Yes?
I don't know if it's relevant, but what's the absolute value of like an imaginary number? Like
That is another lesson.
okay.
We will talk about that in Math 4.
Okay.
But absolute value of an imaginary number, if I want to give you an idea, imaginary number can be assumed as a point in the plane. The absolute value of that is the distance from that point to the origin.
Okay.
That is the absolute value of a complex number.
But you'll talk about it in Math 4.
Yes. Now you are replacing Cameron now these days. He's not here, you're asking on his behalf. Yes. Okay. Yeah. Okay, so do you understand what's going on? Now, let us go back to the important question that Nicholas actually asked. Okay, so let me, this might be very trivial for you, but that's a very deep question. So if I ask you 5 plus 5, you can write it as 2 times 5. If I write x plus x in algebra x is sitting instead of a number. So whatever you can do with numbers, you can also do with variables, because by convention, these x's are actually, these are representing numbers, yes? So this becomes 2x. But what actually Nicholas asked is deeper. Is a plus a is equal to 2a? I want to try to say that this is not trivial as before, even though this is true again, but there is a why for it. Yes, you cannot say because this is true for numbers, because this is true for variables sitting instead of numbers, so I take this for granted that this is also true for vectors. First of all, do you digest this, what I said? In mathematics, the whole point is that the rule of the game is this. You are not allowed to move slightly even that left side to right side. You need to go straight, exactly follow the rules. Follow the rules exactly. This is a better sentence. So you cannot say that because in algebra, once upon a time, I learned that x plus 2x is 2x. So from now on, whatever plus itself is 2 times that number. But you need to motivate. This is not the case. This is a new topic. So, but we want to convince ourselves that this is indeed the case. How should I do that? Let us draw a vector. For example, let me draw with the black. It's easier to see. So let me draw a vector for you here. Let me call it vector A. This is the new lesson, 2 times A. Is this the new lesson or an old lesson? Old lesson. So what I am claiming that the result of this operation that you learned before coincides with the result of this operation that you learned today. And this is not trivial at all. Yes? So if I ask you, can you do this one? Can you construct this vector for me? How do you do that? You remember, I need to add a vector to itself. So, but this is my vector. If I want to add the vector, what I should do? I need to parallel transport this from the tip of this one. You agree?
Just continue the line.
Just to continue the line. So if this is A, I want to add A with A itself. So what I need to do you remember, if I want to add A with B, what I need to do? I need to keep the A the same, and I parallel transport this and draw it from here. But in this case, the vector B is also the same vector. So I need to parallel transport it and put it here. So if I ask you what is this new one, you would say this. Let me draw this with blue here. So if I ask you add A plus A based on what you learned before, you would say that I parallel transport the A from the tip of itself. And then what I need to do, I need to connect the first initial point to the final point. Yes? So what will happen? This will give me this vector. If I ask you what is this vector, you would say this is A plus A. Okay? Now I am asking you, what is 2A? If I ask you what is 2A, do you agree that this one is also 2A? Yes, because it is parallel to the original vector. Yes, the length of it is 2 times larger because I copied and pasted one copy of that here. So it is clear that the length is 2 times larger. And I have kept the direction the same. You see, the direction is here. So on the one hand, this arrow has this name based on what we studied before. On the other hand, this arrow has another name based on what we learned today. But these are 2 names for the same object, so they have to be the same. So this is the proof. So you cannot say I take this for granted. Okay? Now, so this is a very important fact I wanted you to know. So for example, another trivial thing is, it might be trivial, if I have 2, and then I multiply it by 3 times A. What is the first thing that comes to your mind? What is the answer? Yes? Yes, if everything is going as natural, it should be 6A. Yes? So it is 6A. But that is also possible. If I want to draw 6A, what should I do? I need to multiply the length of A by 6 times. Yes, 6 times. And then keep the direction the same. So that would be a vector whose length is 6 times larger than this vector. And then what happens? Yes, the direction is the same. But what happens here on the left-hand side? First, I draw the 3A. So it means that I draw 3 times larger with the same direction, with the same slope. And when I get the answer, I draw 2 times that vector. Again, I need to do 2 copies. So it means that at the end, how many copies I will have? I will have 6 copies. Okay? I don't want to go deeper than that, but I want to tell you that it is very important when you do something in mathematics. This is what I'm saying, that this is an abuse of notation. Yes? This symbol that you see here, you learn in primary school. I am abusing this notation. I am using the same symbol for something totally new. You see, if you want to feel it from perspective of a primary school person, you cannot teach a primary 7-year-old kid to add 5 plus 5, and in the exam give them 2 arrows and then say, if you understand everything, please add these 2 arrows. Even though I am saying add the arrows, I am saying add the numbers, I am doing totally different things. This is very important from a mathematical point of view. Yes?
How is it abuse of notation if it's correct?
No, the reason is that, so the first thing that we learn in mathematics is based on numbers. Okay? We can, for example, for example, assume that you have a game called chess, okay? And then if you go and see, people have invented the chess with 4 opponents at the same time. So you have seen that. So people are fighting, there are 4. But this is an extension of what we learn as chess. Okay? So it might be people have sit down and seen that, okay, chess is a nice game. Why? But it is engaged with 2 people, and if you are a group of friends, 4 people in a group, and 2 should go and cook for you, and then you can play. Okay, is it possible to invent a new game so that everyone can sit down and play? This is the way mathematics actually work. Of course, then you can start doing backgammon. Okay, that is a totally different game. Either you can rule out, I don't know, ruin the whole structure and make a totally new structure. That's also sometimes possible. But usually, that is not very optimistic. In technology, if you have an airplane, it was not that, okay, we are actually riding a horse and suddenly we are now going to the moon. Little by little, we actually developed, yes, these technologies. And that's also the same mathematics. When we learned about numbers, which was more or less the very natural step to start mathematics, we want to build on new things based on what we know. Okay? So somehow this notation and this notation, I want you to see that they are different, because this is between 2 vectors. It's telling you how to add 2 vectors. This is telling you how to add 2 numbers.
But it still has the same results.
No, not the same result. This is what I want you to understand. The result of this is a number. 5 plus 5 is a 10. 10 is just a number. But the result of this is a shape. I start with a shape, this arrow. I add an arrow to it. This is not trivial, how to add arrows. If I didn't taught you, how do you know how to add arrows? So I told you how to do that. And then the result is not a number. The result is another object, an arrow. Okay? Let us continue a little bit faster. Okay, so is that clear now here? Now let me write the rules here for you. And I want you to help me to write these rules. All of them, I guarantee you that if you want to see the proof, it is possible. But I don't want to go through it because this is beyond the lesson. But I want you to participate in guessing based on your instinct what would be the other side. Okay, so I would write it as a remark.
Remark. Isn't it just a by convention?
No, this is not a convention anymore. Convention means that there is no reason for that. This is also good to know. This is why I'm saying that by convention I agree to do this. Okay, but when I say remark, or I should say theorem, it means that there is a reason for that. Okay. So one thing I want to ask you, okay, if I have alpha, so alpha and beta are real numbers. Okay, A and B are vectors. So in what I want to write, I have these things. So number 1, what do you think will happen if I multiply any number, even if I don't know it, by the 0 vector? What is the answer? What do you think would be the answer? Yes?
0 vector.
0 vector. Am I allowed to write just 0?
No.
No, because we learned that if I multiply a number by a vector, by definition, it is supposed to be another vector. So alpha times this is not 0, is the 0 vector. Do I need to know the value of alpha to make sure this? No. Alpha can be any number that you like. Number 2. What happens if I have the 0 number multiplied by any given vector? You see the difference? Here alpha is a number, 0 is the 0 vector. Here 0 is the number, A is any vector. But what do you think would be the answer to this as well? Yes?
0 vector.
0 vector. So when you want to multiply any number by the 0 vector, you don't need to know the number. The answer is the 0 vector. If you multiply the 0 number by any vector, you don't need to know the vector. The answer is the 0 vector. So number 3. Now I'm asking you, what do you think will happen if I multiply 1 by any vector? It's just everyone.
It's the vector.
It's the vector itself, and it is natural. So, and then number 4, what will happen if I multiply -1 by my vector?
So be 8.
Yes, everyone.
Negative.
Negative a. You might say this is trivial. It is not. We'll learn today how to do this. We knew about this in the previous session. I told you how to draw the opposite vector. Today, I told you how to multiply a vector by a negative number. If you do these two things together, you will see that the answers are the same. So number 5. So number 5, what will happen, do you think, if I add two vectors and then multiply a number to it? These are actually, if you want to do more higher mathematics, you can convince yourself that this is the case. I just want to write the result for you here. This is not part of your lesson, but I want you to know. Yes, Benjamin? Yeah, it is a vector, but what can I write? For example, if I give you with numbers, the good point is that the algebra follows the same algebra as numbers. If I tell you what can you write in front of that, what do you write? You remember you could multiply, yes? You can distribute it here. And then fortunately, this will happen here, yes?
Yeah, so it's alpha A vector plus alpha B vector.
Exactly. So it means that I can distribute a number into the sum of two vectors if you want to. And also you can multiply, you can add two numbers first and then multiply it by the vector. Or what do you expect you can do instead? So let me tell you, this tells you that you can first add the vectors and then multiply alpha. This tells you that no, you can multiply alpha to the first vector, you get a vector, you can multiply this alpha to the other vector, and then you add the vectors. The results are the same. If you want to think deeper, you can try to prove this one yourself with pictures and everything, but that's not part of your lesson. What do you think here? This tells you that if I have two numbers, there is no difference if I add the numbers first to get a new number and then multiply it by a, or, can you tell me? What do you think intuitively? Or what I can write? Yes?
Alpha A vector plus
Yes?
beta A vector.
A vector, exactly. So even though they are not trivial at all, but I want you to know about these things, that they are correct. Okay, and finally, number 7, let me write it here. It doesn't matter if I have a vector, if I multiply this by a number called beta, this becomes a new vector. And then after I found the new arrow, I multiply it by another number. There is no difference if I multiply the numbers first to get a number and then multiply that number by the vector. So these are very, very important, but I want you, I know that this is a little bit hard. If you understand these things better, if not, just leave it, okay? But I want you to have this information. This way of thinking, I just want to give you some motivation. This is the axioms of what is called in higher mathematics vector spaces. Vector spaces is the first mathematical structure that you can think of higher dimensions. So using about these things, by the way, in mathematics, it's very easy to talk about higher dimension. In physics, it is very hard. Because in physics, you want to realize the higher dimension. If I say that I have another dimension out of it, I have 3 dimensions here. I can go up and down. I can go left and right. I can just back and forth, yes? So these are 3 dimensions. But if I ask you, can you imagine the 4th dimension?
No.
It is not easy to geometrically imagine that, but it is mathematically easy. And then how you improve the notion of dimension comes from this way of thinking. So this is why I'm saying that this becomes super important. If you don't think that this is just very trivial things. No, it's not trivial at all. So you realize the vectors, something very useful for us. Then I will say that, okay, can I abstract it? Can I think about the vector as an abstract object? Thinking in this way will give rise to advanced mathematics. Using that mathematics, you can do a lot of calculations in higher dimensions. And then, of course, if you get the result, you can go to the laboratory and then test them. The answers are according to what you have calculated. And that's very, very strange, by the way, why mathematics is so powerful in the universe. Yes?
Can you prove the fourth dimension of math right now?
No. I don't want to go through it right now, but but I want to try to say, if you want to think about higher dimensions, something starts like this.
What about tomorrow?
No. Okay, let us continue. Okay, so let me ask you to do something here. A little bit more advanced problem, but that's at the level of your lesson. So example. So let me give you a picture here. So here I have a vector, for example. Let me put these, I don't know, these grids on that. I mean, this is 3 units. I will call it A. Okay, and then 1, 2, 3, 4, 5, 6. Okay, let me the other one 2 times larger than that. For example, here and here. Yes. So 1, 2, 3, 4. Yeah, 1, 2, 3, 4, 5, 6. I mean, this is 3 length unit. This is 6 length unit. I have given you 2 vectors like this, and I ask you to construct this vector. And I ask you to construct this vector. So this is number 1, number 2. 1 over 2b minus 2a. So this is something I want you to learn. Okay, so I have given you a picture including 2 vectors. I have put these dashes on it to emphasize that this is 3 length unit and this is 6 length unit. Yes? And I want you to construct 2a plus 1/3 of b. This is something that you need to know very well. Okay, is that so? Can you tell me how should I do for the first one? Do you have any idea how to do that? Yes?
Well, if you said that b is twice the magnitude of... Oh, wait, never mind. Well,
No, just give me the strategy. I don't want you to give me the details. What should I do?
I was wrong, but well, you could start off by drawing out 2a, like what
Exactly. And then
draw out what 1/3 of b would be.
and then I will get 2 arrows. Forget about the names. I want to add 2 arrows. I know how to add them. Yes? As simple as that. So what should I do? If you want to, don't mess this picture. Let me go here. So from here, any point you like. So Rocco just told that I want to construct 2a. Okay, so how should I construct based on the lesson today? I need to draw a parallel line to that. So I will try to make it parallel. Hopefully it will work from your perspective as well. Okay, and then what should I do? So if you don't mind, just save the space. This is good. I have a lot of freedom with vectors. Let me start from here. Okay, this is 3 length units. I learned how to do 2a. I need to double it. So if this is one of them, this is another one. So this point and this point. So this is my vector. Where should be the tip of the arrow? Up or down? Up, because 2 is positive, so I have keep the direction. So I hope that you agree with me that this is more or less the same, the 2a. Yes? And then what I need to do, I need to draw 1/3 of b. So 1/3 of b, where do you want to start to draw it? So that you don't need to do over 2 times. Yes? Where?
I mean, you could start by parallel
No, I mean record. Okay.
Oh, I'm sorry.
No problem.
2a.
Yes, it is better to start from here. Of course, you can start from here. Then at the end, either you need to use the parallelogram law or you need to parallel transpose. So from the beginning, it is better to start from here. But this is 1/3 of b. Yes? 1/3 of b, I need to draw a line parallel to b. Yes? And then what would be the length? This is 6 units. So it should be 2 units. Yes? So it would be here. And then the direction? The same. And then I can get rid of the rest. I don't need it. So if I ask you what is this, you would say this is 1/3 of b. forget about the names. What you have two arrows. If you don't look at the names, you have two arrows again. You want to add them. So what should I do? Do you remember? The initial point should be connected to the final point. And then where the tip of the arrow? At the final point. So this vector that I have here is 2a plus a third of b. This is the way that you construct this. Yes? Is that clear? Okay, I think this is also simple for you. So we want to do this, 1 over 2b minus 2a. Let us do it together. You can do it in different ways. I don't know which one do you prefer. The first thing, let us do 1 over 2b. Yes? So you choose a point wherever you like, and then you draw 1 over 2b. Where is 1 over 2b? So I draw a parallel line with b. This is my b. 1 over 2. What would be the length? This is 3. This is 6, so it would be 3. So I will take this one and put it here. And I will clean the rest. I don't need it. Because 1 over 2 is positive, so this direction should match with the direction of b itself. So this is 1 over 2b. Okay, now tell me, what do you want to do with negative 2a? There are two different ways you can do that. You can draw 2a, but then subtract them. Or in the beginning, you can do minus 2a and add them. It depends which one you prefer. So what I'm trying to say, you can construct this one, which I have already done. You can construct this one, and then you have to subtract them. Or you can do this in this way. You can construct minus 2a and then add it to this one. Do you remember? That was the way that we defined the subtraction of two vectors. Okay, I don't know which one do you prefer. Okay, so let us do at least this one, for example. If I want to do this, I want to draw 2a. Which one do you prefer? 2a is 2 times a, but in which direction? In the same direction as a. Yes? So it means that I draw a parallel line to this. Hopefully this will work. A parallel line. This line is parallel to a. And I multiply this by 2. So it becomes 6 length units. But I want to draw it from this one. I hope that you remember what to do that. So this one, 1, and then I have 2. So it's up to here. If I ask you what is this vector, and I get rid of this one. So if I ask you what is this vector, you would say this is 2a. Agree? Yes. But remember, I intentionally drew it from the same common point. Do you remember I told you that there are two methods for subtraction? I want you to know them. Either you make it negative and draw it from the tip of the other vector, or you draw them from the first one, but you need to remember how to do it. Do you remember what to do it? Like parallelogram. Do you remember? I drew. This is a very important picture. Whatever you forget, please don't forget this one. If I have two vectors here, starting with the same point, if I complete the parallelogram, this diagonal is a plus b. The other diagonal is a minus b. But if you write a minus b, you have to put the tip next to a. If you write b minus a, you have to put the tip here. So this is a very typical picture you have to have in your mind, especially next year. I don't know, especially if you work with mathematics and physics. This is a very important thing. So now, can you tell me what should I do here if I want to construct 1 over 2b minus 2a in this picture? Gustav is answering more questions today. Yes, Benjamin?
Draw a vector from 2a to 1.
So you mean that I connect these 2 points? That's correct. But tell me that the tip of the arrow should be? Yes, next to b. Because this one carries the positive sign. Yes, thank you. So this one is the vector 1 over 2b minus 2a. Okay, so for practice, let me do this one again. Let us do this one again. So how do you do that one? Can you help me? So if I want to do this one, 1 over 2b is the same thing. It doesn't change. So let me just draw this one from here. So 1 over 2b is this one. Hopefully the size is the same. Okay, but now I want to add it to negative 2a. What is negative 2a? Negative 2a means that I need to draw this parallel. Yes. Okay, because I want to add, even though I can start from here, but it is better to start from the tip of this b, yes? Because I want to add. For adding, the tip of the vector is better. So this is the parallel line to the vector a. It should be 2 times larger, but with negative sign. So it goes in which direction? Unfortunately, I don't have enough space, so let me clean everything again, sorry. I start from here. This is 1 over 2b. Let me write it here. Okay, so that is 1 over 2b. Then I draw a parallel line to this. Okay, and then I want to start from here, but this times it is negative 2a. So I need to make it 2 times larger, but I need to put a direction here. So this is 1 times larger, another times larger here. So I will connect this one to this one. So if I ask you what is this one, then you will say that this is nothing except minus 2a. And now I ask you to add them, okay? But this is the standard way of adding the arrows. You need to connect the initial point and to the final point, and then you put the arrow here. So what you get is again the same thing. So if I draw this 100% precise, what you get at the end is parallel to this one. It will point in the same direction, and it will have exactly the same size. The reason that there are some discrepancies here is because I'm doing it with hand, and it is not very precise. But these are 2 ways to do that. Yes?
Yes.
Is that clear?
Yes.
Okay, so I will just teach a little bit more until 1:15, and then we can stop. Okay? Now, let us do some interesting problems. Yeah, one interesting problem. I want you to see how do you think about this. Any questions? Is that understandable or hard? Yeah, very good. Okay, so let me ask you a little bit hard question. Can you answer this question to me? So, example. Let A, B, C, and O be points. Let capital A, B, C, and O be points for which I have this relation. 5 times the vector OA minus 2 times the vector OB minus 3 times vector OC turns out to be the 0 vector. Okay? Show that A, B, and C lie on the same straight line. Okay, now let me use this as an excuse to teach you some geometry. First of all, let me ask you, how many lines passes through one single point? Infinitely many, yes? So if I have one single point, assume that this is the point, just don't look at my finger, just the tip of my finger, and this is the line. All these lines are passing through that point, infinitely many. But this, I want to ask you, if I have 2 separate points, and if I ask you how many straight lines, not curved ones, how many straight lines passes through that 2 points? How many?
Infinitely.
So let me ask you. So you see, I put one point here, Let me call it A. Forget about this example for the time being. And this is another point. I want you to imagine a line or lines that contains these 2 points simultaneously. And I am asking, how many of them do you think are there? Yes?
I was counting two, but I remember lines from the direction.
So your answer is 1.
Yes.
Do you agree with him? Yes, there is only 1. Okay? If you want to imagine it, how many points are passing through this? There are infinitely many points, even in a space, in the plane, and some of them are from space going here, yes? Infinitely many points around this. But if I want to consider another line which also keeps this one, there is only one possibility, and that is this only line. There is no other line for that. Yes? Is that clear? So 1 point, infinitely many lines. 2 points, suddenly 1 line. And 3 points. What about 3 points?
Also one line.
Uh,
How do you put it like this?
exactly. It depends. So the answer to the first one doesn't depend. It is always infinitely many. The answer to the second one is always 1, independent of how I choose the points. No? But if I say 3 points, you say that it is not clear. It depends to the position of the points. If you draw 3 points like this, then how many? There is 1. But if you draw the points like this, how many lines are there containing all of them? 0. So this is not trivial at all. Okay? So now here I am telling you that there are 4 points. That, by the way, there are 4 points. They can be on the same whiteboard plane, or 3 of them can be in the plane, but 1 of them can be outside. So 4 points can be outside in a space, or they can be on the plane. But now I'm asking you, I have 4 points. I don't know. They are 4 points in a space. I know something. I know 5 times this vector minus 2 times that vector minus 3 times of that vector is suddenly equal to 0. I want to claim that if this happens, I know that A, B, and C are lying on the same line. It's not that trivial. Okay?